I've never seen a Kia Sedona that was this badly damaged. Cylinder bore damage alone is already serious, but we also had to realign the main bearing bores because overheating crushed all the support surfaces. We had to recut new seating surfaces, especially. We even had to recover the piston crown. Those of you who run service vehicles know the Kia Sedona well. This one is a diesel engine with a cast iron engine block. It's the older version of the Kia Carnival. To be fair, the older Kia Carnival models are much more durable than the newer Carnival generations later on. However, if it's not taken care of properly, and maintenance isn't done correctly, it will still break down. As you can see, the engine block still looks very new. The owner said the engine has been rebuilt 2 or 3 times, but it always had engine knocking noises. Sometimes during operation, the oil pressure warning came on when we removed the crankshaft for inspection. Visually, I felt something was wrong with the main bearing lining process. As for the piston and cylinder wall, they do show signs of wear, but I don't think they caused the knocking noise. I don't believe they were responsible for the knocking sound described by the customer. The cylinder walls are completely worn out. There's no crosshatch pattern left at all, but there are no deep scratches or scoring. The only issue is the combustion efficiency is reduced. The vehicle may feel weak instead of powerful. Now we begin the machining process. Actually, before machining, there is a measuring step called engine inspection and measurement. When we perform this measurement, we can identify all the engine's issues. From there, we decide on the proper machining solution. And the most critical part of this engine block is the main bearing bores. When placed on the milling machine and checked with a dial gauge, these main bearing bores are not concentric with each other. They are misaligned by about 0.3 to 0.4 millimeters, which is more than enough to cause serious crankshaft issues. Clearly, the main bearing clearances were set very loose before, during previous repairs. Because if they weren't loose, when tightening the bearing caps, the crankshaft would seize. Since the bearing bores were misaligned, and because the clearances were too large, the engine could not run smoothly. Oil pressure could not build or lubricate properly, resulting in knocking noises. Oil pressure was extremely low, as you can see. I've positioned the engine block vertically onto a vertical milling machine to remachine the bores concentrically from top to bottom. All 5 main bearing bores. This process is commonly called block line boring. I also have a line boring machine and even a dedicated honing machine, but in some situations, I still prefer using the milling machine like the one shown in the video rather than line boring machines. It's easier to align and extremely fast. Set the cutter once, press the button, and run from top to bottom. The accuracy is very good. Tolerance is within plus or minus 0.005 millimeters, which is totally acceptable after machining. Now the technician has finished line boring the block. As you can see, all these bores are now perfectly concentric. Secondly, the diameters are exactly to specification. Next, we move on to installing the cylinder sleeves. Installing sleeves is a very routine process. There's really not much to explain here. We already removed the old sleeves at the beginning of the video. Once the new sleeves are machined, they are pressed into the block. In some cases, we use a hydraulic press. In other cases, we install them by hand. It really depends on the situation. These new sleeves here are not fully finished in size yet. They still need a few more machining steps to be truly complete, especially the step of resurfacing the block deck. This step is mandatory. If the block surface isn't perfect, the head gasket will definitely fail. The final step of block machining is finish honing. This uses a honing stone, not a cutting tool. There is no centering and no tailstock support. No fixtures at all. This is not turning. This is honing. The purpose of honing is to achieve the most accurate dimensions possible. Far more accurate than cutting tools. It also creates the crosshatch pattern. As you can see here, this crosshatch pattern is the lifeline of the engine. It helps create the best possible combustion seal. Once the block is done, we move on to the cylinder head. The cylinder head is in very bad condition. All the valve seats are severely damaged. It seems someone previously forcefully sandblasted it, almost in a destructive manner. So the valve seat surfaces became very wide, very rough and heavily deformed. Now we proceed to recut the valve seats, cutting 3 angles: 30 degrees, 45 degrees, and 60 degrees. After cutting, the seal is perfect. No lapping or grinding is needed. These valve seat angles improve both intake and exhaust flow of the airflow. Whether a cylinder head performs well depends largely on the valve seats. On passenger vehicles, we may not pay much attention, but on race cars, the valve seats can determine winning or losing. For sure. Machining is now complete. It's time for assembly. As mentioned earlier, the most critical part of this block is the main bearing bores. The technician is now preparing to install the crankshaft, installing the main bearing caps, then applying grease to the main bearing bolts. This is special assembly grease, not the regular grease we normally use. This grease is specifically for tightening bolts. The goal is to reduce thread friction as much as possible, so the clamping force is as accurate as possible. When we do line boring, we also torque the bolts in exactly the same way, so that the dimensions after machining match the dimensions after final assembly. Torque tightening is done into steps. The first step is torque tightening. The second step is angle tightening. The torque wrench in the video can handle both torque and angle tightening. Everything rotates extremely smoothly. Oil clearance is exactly to manufacturer specifications. The most critical engine issue has now been resolved. As for the remaining details, they are fairly routine procedures. One thing to pay attention to is the pistons. Those experienced in machining may be wondering. When we line bored the block, we shifted the crankshaft centerline slightly closer to the deck surface, and that's something we have to accept. As a result, the piston crown sits higher than normal by a certain amount, which we can measure. To bring it back to specification, we must machine the piston crown. This has nothing to do with compression ratio. In English, this is called squish distance. In Vietnamese, I honestly don't know how to translate it properly, but it is definitely not compression ratio. So machining the piston crown here is not for calculating compression. Please don't misunderstand. In English, it's called squish distance. If you're curious, you can look it up on Google. And the process continues like this: installing the cylinder head and torquing it down. Once again, this torque wrench can apply torque and angle tightening as well.